All right, let's talk about Go. You've probably heard it's famous for concurrency, but what does that actually mean? How do you use it to write really fast, really efficient programs? Well, today we're going to break down the essential patterns, starting from the absolute basics and building all the way up to the pro-level techniques that will seriously level up your code.
So here's our game plan. We'll kick things off with the big ideas, the core concepts. Then we'll get into the essential building blocks. After that, we'll see how those blocks create your everyday toolbox of patterns. And then we'll dive into some more advanced stuff. And finally, we'll wrap it all up and see why this stuff really matters.
Okay, first things first. Before we even think about writing a single line of code, there's one really important idea we have to get our heads around. Nailing this concept is the key to unlocking everything else. Let's get this straight, because a lot of people mix this up. Concurrency is not the same as parallelism. Concurrency is about how you structure your program. It's about dealing with lots of things at once, like a single chef juggling multiple steps for different recipes. Parallelism is about doing lots of things at once, like having multiple chefs each working on their own recipe. Go makes it super easy to write concurrent code, and then the Go runtime can execute it in parallel if you've got the hardware for it. So how does Go make this all so simple? Well, this is the amazing part. This whole powerful concurrency model, it's really built on just two super elegant concepts. First up, Goroutines. Now, don't even think of these like old-school threads. They are incredibly lightweight. The Go runtime handles them, and you can spin up thousands, even millions of them without breaking a sweat. You just put the keyword Go in front of a function call, and poof, it's off and running in the background. Okay, so if you have thousands of Goroutines running around, how on earth do they talk to each other without causing total chaos? Well, that's the second piece of the puzzle, channels. If Goroutines are your workers, you can think of channels as the conveyor belts between them. They're how you safely pass messages and make sure everyone is working in sync. And that's really it. Just Goroutines and channels. Seriously, with just those two simple building blocks, we can put together some incredibly powerful solutions or patterns for all kinds of common problems. Let's check out the first one. So here's a classic situation. Let's say you have a massive fire hose of jobs you need to process. Maybe you're resizing thousands of images or crunching a bunch of data. If you start a new Go routine for every single job, you're going to overwhelm your system and bring it to its knees. So how do you manage that workload? The answer is a well-known pattern called the worker pool. And the best analogy for it is a supermarket. You don't open a new checkout lane for every single customer, right? No, you have a fixed number of lanes, your workers, and the customers or jobs line up. The next available cashier takes the next person in line. It's organized, it's efficient, and it's controlled. So here's what the machinery looks like. You've got one channel for all the incoming jobs, then you have your fixed number of worker Go routines, all pulling jobs from that same channel. You'll often have a third channel for the results to flow back into, and that last piece, the sync.wait group, is super important. It's basically a counter that lets your main program know, hey, hold on, wait for all the workers to finish before you shut everything down. Okay, but what if your problem isn't a million tiny jobs? What if it's the other way around? One single, giant, slow task. The answer in this case is to divide and conquer. Think about translating a huge book. One person doing it alone could take weeks. But what if you fan out the work? You give 10 pages to 10 different translators. Then, once they're done, you fan in all their completed work to a single editor to assemble. You get the same result, just way faster. So to put it simply, fan out is that first stage, where you distribute the work out to a bunch of different Go routines. And fan in is the second stage, where you gather all the results from those Go routines and merge them back into one single stream. Fan out, fan in. Together, they create a really powerful pipeline. All right, those patterns are your bread and butter. But as our applications get bigger and more complex, we're going to need some more sophisticated ways to coordinate all these Go routines. And this is where some of the real magic of Go concurrency comes into play. It's called the select statement. You can think of it like a switch statement, but for channels. It lets a single Go routine listen to a bunch of different channels at the same time and just react to the very first one that's ready. In fact, we can use select to build that fan-in pattern we just talked about. So imagine we have a function that needs to take two input channels and merge them into a single output channel. The function signature would look something like this. Now inside a Go routine, you'd have a select block like this one. It's just sitting there, waiting. It's got its ear to both channels 1 and channel 2. The instant a value shows up on either channel, that case runs, it grabs the value, and sends it down our single output channel. It doesn't play favorites. It just goes with whichever one is ready first. And this is the beauty of it. The part of our code that uses this fan-in function, it has no idea about all that complexity. It's just happily looping over one single, simple, merged channel. All the tricky logic is hidden away. Now, for any real-world production-level application, you absolutely need to know about the context package. This is non-negotiable. Think about it. A user hits cancel on a web request. How do you tell all the background database queries and calculations to stop? Context is how. It's the standard way to handle cancellation, timeouts, and deadlines across your entire application. And believe me, we are just scratching the surface here. There are tons of other advanced patterns, like bounded parallelism, which gives you even finer control over how many things run at once, or the T-channel pattern, which lets you duplicate a single stream of data so multiple listeners can process it at the same time.
Okay, we've covered a lot of ground, from the simple building blocks all the way up to some pretty complex patterns. So let's bring it home. Why is getting a handle on this stuff so important for a Go developer?
Because this isn't just about cool programming tricks. This is what separates good Go code from truly great Go code. These patterns are the key to building applications that are not only high performance and scalable, but also clean, easy to reason about, and maintainable in the long run.
So, we've given you the building blocks and we've shown you some of the blueprints. From here, the possibilities are pretty much endless. The real question is, what amazing things are you going to build with them?